Now in this lecture, we will study the timing diagram of 8085. Now what is timing diagram? It represents the execution time taken by each instruction in the graphical format. The execution time is representing T states or clock pulses. Now these are the control signals. Already we have studied these control signals in the architecture. If this is 0, S0 and S1. If both are 0, then halt, 0, 1, write operation, 1, 0, read operation. Now we included the IO oblique M bar. Now IO oblique M bar are active low signal. So if this is equal to 0 means what? It is a memory operation. So all are 0 means halt. 0, 0, 1 means what? 0, 1 is a write operation. Again, it is 0 means what? Memory write. Now 0, 1, 0 means what? 1, 0 is read operation. Here IO oblique M bar is 0 means memory read operation. By say IO oblique M bar is equal to 0 means we are selecting the memory. If it is 1 means we are selecting the IO devices. Similarly, now here you can see that 0, 1 means what? Write operation. And now this bit is equal to 1 means IO write. Now 1, 0 is read operation and the bit is equal to 1 means IO read operation. Now 0, 1, 1 means what? Upward fetching. So upward fetching can be done only from the memory. That's why what? Here need to select 0. Now all are ones means what? Interrupt acknowledgement. Acknowledge. So now next one is what? Instruction cycle. What is instruction cycle? Cycle. The time required to execute an instruction is called the instruction cycle. Now, in complete instructions are divided into the machine cycles. Now, what is machine cycle? The time required to access memory or IO devices is called the machine cycle. Nothing but what? Memory read, memory write, IO write. For that, how much time it takes uh, to read and write, how much time it takes, that is nothing but a machine cycle. Now, T state. The machine cycle and instruction cycle takes multiple clock periods. The portion of an operation carried out in one system clock period is called as a T state. Nothing but what? This is the clock, and in this is called the clock period. From falling edge to falling edge again, this is called the clock period. This clock period in this timing diagram, we are calling it as a T state. Now, machine cycles are here, 5 basic machine cycles are available. One is upward fetching. For that, 4 T states are required, or 4 clock pulses are required. Now, again, memory read, memory write, IO write. These are the read write instructions. For this, 3 T states are needed. Now, first we will try to analyze the upward fetching. Now, before that, what memory, the processor takes a definite time to execute a machine cycle. The time taken by the processor to execute machine cycle is expressed in T states. Now here machine cycles and instruction cycle, all are instruction cycles are divided into machine cycles, and these machine cycles we are representing by using the T states. One T state is equal to the time period of the internal clock signal of the processor, and the T state starts at the falling edge of the clock. Now here you can see the upward fetching. Now from the falling edge to the next falling edge is called as a 1T state. Like that, for upward fetching, total 4T states are required. Now 3T states are needed to fetch the upward from the memory. Fetching upward is nothing but what? Reading the upward from the memory only. And the 4th T state is needed for the internal operation of the microprocessor, or nothing but you can say it as, once the output is fetched, that is placed in the instruction register, and after that it will be decoded. For that, what? Needed one clock cycle. So decoding is taking place in this T4 clock cycle. Now to fetch the output, what we need? So processor will place the address on the address bus. Now address bus is divided into higher order address bus and a lower order address bus. Now higher order address is placed on the higher order address bus, and lower order address bus is placed on the multiplexed data address bus. It is placed on this bus. When the ALE signal is enabled at the beginning for any machine cycle, ALE will be enabled. But when the ALE is enabled, this bus is acts like a lower order address bus, and for first one clock pulse, only one T state, and after that ALE becomes 0. So this bus acts like a data bus. Now, once the address is placed for first clock pulses, it will select the memory location in the memory. Now, if this is a memory location, it will select the memory location. And once the memory location is selected, read signal is applied. Read signal is applied. Processor will place the read control signal. Thereby, whatever the opcode is, now memory is location is selected and the read signal is applied. Now, whatever the opcode is placed in this memory location is this opcode is placed on the data bus. Now here the opcode is placed on the data bus. Now this is for only 3 clock cycles. Address is available up to 3 clock cycles and also data is available up to 3 clock cycles. Now after that you can see this dot 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 nothing but what if this is a this is called as a logic high and this is called as a logic low. So now if it is in between means what? This is called as a high impedance mode. High impedance mode. This is called as a neither logic 0 or not logic 1. So now here if we are representing only the single signal, now here you can see the clock, here you can see the ALE, now here you can see the read signal. If you are representing the single signal, that time depending upon the requirement, now here the read is applied at the T at the second T state. Till that time it is what high. High means what? It is disabled. Now to make enable, this is a bar is there, active low signal. When you give the 0, then only it is activated. So here to represent the single signal, so zeros and 1 are clearly we have given. But if you see the address bus and here the status bus, we represented with a now box type diagram we have taken. This is nothing but what? A bunch of signals representing at the at a time. That's why we have to show like this. Now here the crossing is taking place means what? Information is changed. Now the address is placed here. Again the crossing is taking place here means what? Now address is now up to this address is maintained and after that it is changing. Unspecified means what? After that there is no need of any address. Now in a fourth T state, so processor is doing the decoding. So that time address is not required. That's why it is unspecified. Now the data bus is also now here. Data bus is how many? 8 bits. Now here also address bus is 8 bits. More than one signal if you are trying to represent, that time we will represent this signal like this to the box type indication. Now inside we will write the data, whatever the data is there that we will write. So it representing all the signals like this, it is very difficult. Single signal representing 8 bits, 8 bit, 3 bits, it is very difficult. That's why what we are representing all bits, all signals together. Now this is about the read signal. Read is applied and only for 3 clock cycles up to third clock cycle, the read will be enabled and the data will be placed on the data bus. And in the fourth clock cycle, there is no need of read signal, there is no need of data bus, there is no need of address bus. That's why it is unspecified here. So address bus will go into the high impedance mode and read signal will be disabled again. Now these gives the status of the microprocessor. Now fetching the opcode is nothing but what? Accessing the memory. Now, if IO oblique M bar is equal to 0 means what? Selected the memory. If IO oblique M bar is equal to 1 means what? Selected the IO devices. Now, fetching opcode means what? From the memory, it is reading the opcode. So, that's why what? Memory is accessed. That's why we need to take 0 here. And fetching, for fetching, what is S0 and S1? Both are 1. So, that's why need to show 1, 1. So, this is about the opcode fetching machine cycle. Now coming to the memory read machine cycle, memory read is nothing but what? It will read the data operand from the memory. So it is almost like a opcode fetching only. Here we need to remove the fourth T state. If we show up to this third T state, then it is nothing but what? Memory read only. That if only the difference is what? Now here memory read means what? Again you need to apply the read signal only. Only the difference is what? Here you are accessing the memory. That's why you need to show 0. Instead of fetch, memory read operation is taking place. That's why what? S1 and S0 are 1, 0. Remaining complete diagram is the same as it is like a fetch, opcode fetch only except the fourth T state is not absent. That's all. Now coming to the memory write, everything is same like a memory read only. Instead of read signal, need to apply the write signal. Why? Because it is a memory write operation. So for writing, need to apply the write operation. So what is the status bits for the write operation? 0 and 1. Memory means what? 0 only. The remaining diagram is same like a memory read only. So analysis also same. Now coming to the IO read operation. So now in this case, need to apply the IO port address. IO port address here, and here IO port address need to apply. Instead of the memory address, IO port address is needed to be applied. And ALE bit is equal to 1 enabled for the first clock pulse, so that the lower order bit is now lower order bus is acting like a address bus. Now once the port is selected, now this ALE is goes low, and when it is going low means what? This lower order bus acts like a data bus. When the read, now it is a read, IO read. Read signal is applied. Now from that port, data will be placed onto the data bus. Now in the port, IO port, whatever the data is there in the data bus, so that data is placed on the data. Now in the interface, we have a data buffers or data registers. Now from this data will be placed on the data bus. Now here we need to give IO oblique M bar is equal to 1 because IO devices are accessed. That's why we need to apply 1 here. And for read operation, what are the status bits? 1 and 0. So that is only the difference between the IO read. Now coming to the IO write, it is almost like IO read only. Only the difference is instead of giving the read signal, need to apply the write signal. That's all. And the status bits for the write is what? 0 and 1. Now this is about the 5 machine cycles. In the next lecture, we will see the few examples, few instruction. And now complete, now this is a machine cycle. Individual machine cycles we discussed. Now we will see the complete instruction timing diagram in the next lecture.